In this video we are going to discuss about the second law of Newton. Now in the statement of second law, as you all know it, there is a term called momentum. Now what is the definition of momentum? The dynamical property arising from the combined effect of mass and velocity of a moving body is called its momentum. Now what does momentum measure? What does momentum measure? In the first law we came into terms with the word inertia. Now what is the measure of inertia? We all know it. It is the mass which is the measure of inertia. Now in the second law, what does momentum measure? The answer is the quantity of motion. The quantity of motion. Now, as we have stated the word as quantity of motion, so the definition goes as the dynamical property, the quantity of motion or the dynamical property arising from the combined effect of mass and velocity. So momentum is denoted by small p, product of the mass and velocity, mv. Now Newton described momentum as the quantity of motion. Momentum of a body is the product of the mass and velocity. Now a body's momentum always depends on both of the parameters, that is the mass and velocity, not on a single term. Mass is a scalar quantity, whereas velocity is a vector quantity. It has both magnitude and direction. So the direction of momentum is the same as the direction of velocity. In vectorial form we can write it like this. This is the vectorial form. So the direction of velocity, or rather velocity change, gives the direction of the momentum of the body. Now how to understand the concept of momentum? Now what is the concept of momentum? Concept of momentum. Now suppose two identical trucks. Here is one truck, two identical trucks. These two trucks, one is loaded and another is empty. They are moving with the same velocity. They are moving with the same velocity v in this direction. In this case, the momentum of the loaded truck is greater than that of the other truck, because if the mass of this truck is m, we all know that m is very greater than m, because this truck is loaded and this is empty, as well as the velocity is the same. So if velocity is same for both the trucks, therefore the momentum mv is very greater than mv. Now to stop this two trucks within the same interval of time or equal interval of time, the loaded truck will require more force than the empty one. This truck will have to be attended by a more or larger force to stop the truck. But if the trucks are of the two trucks of the same mass and the first one is moving with a higher velocity, the momentum is also higher. Here again the same principle will apply. To stop the two trucks within the same interval of time, a greater force has to be applied against the first one. The second case, the mass of the two trucks was same. The velocity, suppose v1 is greater than v2. This is case number 2. Now the momentum mv1 should be greater than mv2. So the force required to stop this truck would be much greater than this one. Now we take a third instance in which both the mass and the velocity are not same. Suppose we take a truck of mass 10,000 kg and a car of mass 1000 kg. The velocity of the truck is 2 meters per second. The velocity of the car is 50 meters per second. You have to denote by m dash. v dash. Now the same question arises, what is the amount of force required to stop the two vehicles? Which one will be the greater one? The truck has a momentum of 20,000. The momentum of the truck is 20,000. Now to stop the truck, we have to convert this 20,000 to 0. As when the truck stops, the velocity of the truck will become 0. So the change in momentum will be from 20,000 to 0. Whereas for the car, the change in momentum will be 50,000 to 0. Now this will require more force to stop. The unit of momentum, the SI unit of momentum is kg meter per second, and the CGS unit is gram centimeter per second. M into V. M means mass, kg. V is the velocity, meter per second. Similar is the case here, gram centimeter per second. The dimension of momentum, ml t minus 1, mass into the dimension of the velocity. The second law of Newton's laws of motion, it is the rate of change in momentum is proportional to the applied force, and the change takes place in the direction of force. There are two parts in this statement. One is the rate of change in momentum is proportional to the applied force, and the second part is change takes place in the direction of force. Now what does the first part mean? Larger the force acting on a body, greater is the change in its momentum. Since change in momentum is equal to the product of the mass and change in velocity, and the mass of the body remains constant, so the rate of change of momentum is directly proportional to the rate of change of velocity, that is acceleration. Now how do we prove it? We prove it by stating that the initial momentum, suppose it's mu, the initial velocity is u, product of the mass and velocity. The final momentum is mv. So change in momentum is equal to mv minus mu. Rate of change in momentum is equal to mv minus mu by t. So this is the time in which the change has taken place. Now according to definition of acceleration, that is a change in velocity, the rate of change in velocity, which is known as acceleration. So this is rate of change of momentum is force. Now if mass is constant, we can say that F is proportional to acceleration. The second part, that is the change takes place in the direction of force. It means that if a body is at rest, a force will set it in motion. If a body is moving with a certain velocity, a force will increase or decrease its velocity according as the force acts in the same or opposite direction. Now whenever there is a force acting on the body, there will be acceleration acting on the body in the direction of force. If the force is a resistive force, now suppose a car moving in this direction is stopped by applying brakes. Now if the body is stopped by applying brakes, the force acts in the opposite direction, so the body will slow down. Now the acceleration of the body will be acting in the reverse direction. We said that a retardation comes into play in the forward direction, that means a negative acceleration. So we can consider the positive acceleration acting on the body in the reverse direction. We can also prove this with the help of calculus. Suppose P is equal to mv. Differentiating both sides with respect to t time. So dp by dt is equal to ddt of mv. m is a constant, so m dv dt. Now what is dv dt? Acceleration, so is equal to ma. So dp by dt is equal to ma. From the definition of Newton, rate of change of momentum is the force. Force is equal to mass into acceleration. Now we're going to start with a very important part of the second law, that is the impulse of a force. Now what is impulse of a force? Straightforwardly, impulse means the product of the force and the time. So what is force? Rate of change of momentum into time. So mu into v minus u, that means mv minus mu, or rather you can state it as the change in momentum. So whenever we are asked to calculate the impulse of a force, we can do it in two ways. One is the product of the force and the time it takes to change, and the other form is to find out the change in momentum, mv minus mu. Now the change in momentum of a body is equal to the impulse of the force acting on it, or the impulse of a force. Definition of this force, definition of the impulse of a force: for a constant force acting on the body for an interval of time, and the product of the force and the time interval is the impulse of the force, or simply the impulse. The unit of impulse, the SI unit, is Newton second, because it's the product of the force and time. So force is Newton, time is second, and in the CGS format it is dyne second. The dimension of impulse is the same as that of the momentum, because it is a change in momentum, so m lt minus 1. Now if we are asked to calculate the value of impulse from a graph, suppose in the y-axis is force and the x-axis is time t. Now the force acting on the body is a constant force, so we can find out the area of this rectangle. F into t means the area of rectangle. Now what does this area give? It gives the impulse of the force. But if the figure is somewhat like this, that means the force is not constant, the force is ever changing. The principle is the same. We have to find out the area of this curve, but we have to apply calculus. The form is 0 to t f dt. So the impulse I will be equal to integration of f dt. The limit is 0 to time t, 2 seconds, 3 seconds, 4 seconds, whatever they give, we have to put the value here. Now the second topic, impulsive force. Now this is a force, it is not the kind of thing we have discussed earlier with the term impulse. This is a kind of force which is very large. The characteristics of impulsive force is that it is very large and it acts on a body for a very short duration. Now the calculation of this kind of forces will have to be done according to Newton's second law, that is the rate of change of momentum. But examples of this kind of forces are hammering a nail in the wall, hammering a nail, suppose kicking a football, carom, striking with a striker, striking the beads with a striker. So this has to be calculated as m v minus u into t, or rather ma.